Hello everybody, welcome to another Code Train Bootcamp video. This time we're going to focus our attention on variables and how they work. And in some ways this is one of the most important videos for new programmers, new teachers of computer science to understand, because there's a little bit of background that goes in behind it. And what makes it also really important to understand is different languages treat variables differently. So the p5.js that I've been working with you on this bootcamp actually uses and treats variables in a different way than processing proper, which I have in all my my lesson plan examples. So I want to talk a little about the differences between that, and those differences are common in many different languages. So you need to know how to recognize those differences if you ever do delve into different languages. So what I want to do is start off with something really, really simple in p5.js. And what we're going to do is not really, there's no new code we're going to see on p5.js, but I do want to talk about some of the subtleties of how things are going to work. So what I want to do is I'm going to set up a new variable. And as you'll see, and you've seen it before, that in processing, in p5.js, we use the word var to stand for variable. So let's say I wanted to create a little something. I'm going to work with some math, so I'm just going to call it number, and I'm going to set it equal to 5. So what we've done is we've created a variable called number, and we've put the value into 5, which maybe makes intuitive sense. But I want to talk a little bit about what's actually going on behind the scenes. So what you need to think of and explain to your students is the memory of your computer is like a cupboard. So over here I've got a, oops, we're just going to switch to a different setting. Okay, so over here what we've got is our RAM memory. So we're going to make this our RAM. So this is the main memory we have in our computer. And this is where when you load a program, all of your instructions get loaded into RAM. So what I want you to think of RAM as like a cupboard full of shelves. And so if I want to create a variable called number, what I'm actually doing is I am nicknaming one of these shelves. Now, if you think about the way memory works, if you have like a computer that has 32 gigabytes of memory, that means you have 32 billion bytes, 32 billion characters worth of memory. And if I want to store one character, number 5, I need to know where in memory that is. So what we do is I'll just kind of indicate, I'll put the 5 in kind of that shelf in memory. Now what we need our computer to know is where that shelf is. So each one of these shelves has an address. And those addresses are stored in actually hexadecimal number, but basically it's related to binary and the way that regular numbers work. And so when I put the number 5 in, though, I need to know which memory address that is. So what you do when you create a variable called number, you essentially are giving a nickname to this shelf. So this shelf here where the 5 is now nicknamed number. At any point in time I want to access what's in number, I use the word number. The computer knows that it's allocated to this particular shelf, and I'm pointing at the computer like you can see what I'm pointing at, it will make reference to the number 5. Now in p5.js, that's all you have to do. Use the word var, and it creates that. It nicknames one of the shelves in your memory number. In other languages, you're going to see this a little bit later on, you actually can't just use the word var. They use what are called variable types. So if I want to store the number 7 in a slot in memory in processing, again, I'm going to show you this in a little while, but at the end of this video, is I can't just use the word var, because processing says, wait a minute, var will not work for certain types of things. What I mean by that is, in p5.js, if I wanted to say the letter A, I could just say var letter, and processing says, okay, I got this number, it's going to take care of numbers, I got letter, it's going to take care of letters or words, or who knows what I want to put in it. But in other languages, you can't do that. You actually have to indicate what type of data this is. So 7 is going to be an int. And so I could call that int number 7. If I want to say a word, maybe I want to write the word Bob, then what I do is I have to say it's going to be a string, variable type name. Now, I'm not going to go into the details of that right this second, but I'll show you a little bit later on. So keep in mind that in some languages, you can use the word var, or whatever their key language is. In p5.js, it is var. In other languages, you have to indicate what type of variable, so it knows how much, how big a cupboard, how big a shelf in your cupboard of memory they need to allocate. Okay? So you'll see that here a little bit towards the end of this video when I show you the differences. We'll stick with p5.js because that's what we're used to, and then we'll do the other one here at the end. So I've created a very simple file. var number is equal to 5, and just to indicate what I did before, I'll say maybe name equals, and I'm going to put Julianne, and I've got that. So what I'm going to do with this, just to demonstrate something that's really obvious, I'm just going to use the console.log. So down here at the bottom, you can actually see I've got some for my testing. Some things down here at the bottom I'm just going to print. And I'm just going to use the mouse pressed function just to trigger that. So I'm going to go console.log, and I'm going to print number. We'll do that first, and we'll just run that and make sure that works. And you will see, I mean, no big surprise, 5 is printed here. Now, in case you're not clear, I can also console.log in a number of different ways. I could say name, and I could say plus maybe some spaces, maybe a semicolon, because maybe Julianne is 5 years old. This maybe the number represents her age. Okay, I click there, and there is Julianne's 5. So I guess I kind of did that in a weird way with the semicolon. Okay, so no big deal, makes perfect sense. Now, I do want to show you a couple other things though. So what I'm going to do is I'm going to print a couple console.logs here and show you some of the ways that this computer treats this this variable called number. So first I want to do is I want to show you, and this is not going to be a surprise, what happens if we do a little bit of math on this number. So number times 4, console.log, and we'll see down here that it prints 5 times 4, 20. Okay, so it goes into whatever's in number in the current memory cell, times by 4, and prints it. Now, if I just console.log number again, it probably won't come as a big shock to you that is it going to be a 20 or is it going to be a 5? Well, the answer is it's going to go back to 5. Why? Because we haven't changed number at all. We've never said change whatever value is in this shelf called number. We've printed it with the multiplication, but we haven't done. Now, interestingly enough, I wonder what happened if we printed name times 4. So predict what that's going to do, and then we'll run that. And you're actually going to see that it does something weird. It says not a NAM, which actually stands for not a number. So what it's actually doing is giving a weird error message saying, well, you can't multiply name times 4. Interestingly enough, though, you can add name plus 4, because what it does is it actually says, oh, you must. This is a string. We'll call it a string of characters. You must want me to add this character to the end of that string. So you notice that it does that there. Okay, now all of these are really important to understand, but none of these change the value of number. So just to clarify, if I wanted to say, number equals 7, and then print out number, of course it shouldn't be a shock to say that now I've changed the value of what's in number to be 7. So let's get rid of these others. Let's comment these ones out just so we can stick to the newer stuff. Okay, so there's my number 7. Okay, now but here's another way to change it. You can do this. You can say number equals number times, let's say we want to times it by 3 to get our number, to get 21. So now we say make the value of number equal to the current value of number times 3. Print it out. Let's make sure it does indeed change the value to be 21. There we go. So it does. The other thing you should know of as a teacher, you're going to see really early, is some shortcuts. This thing happens so often in computing science when you want to change the value. They developed a shortcut for it. And so that shortcut is say number equals, but whatever you do is you use plus equals or times equals, notice asterisks for times, I actually didn't necessarily say that earlier, or divide equals. And what that does is it says, divide is a slash, is it says change the value. So it's a shortcut for saying number equals number divided by something. So if I want to divide, what was I, 21? So let's say I divide by, let's just say 6. That'll give us a decimal number. And print And there it is, my 3.5. So you can see that it's altered whatever value is in number because it's printing the new value number out. You'll also notice something that is important because it's going to work differently in processing is that it had no problem switching to decimals. VAR can handle anything, so as long as it knows that sees that there's decimals in this number, it's going to now start storing decimals like you'd expect it to. Okay. Now, here's something that's kind of interesting though. This divide by would actually work differently in processing. The name the name times 4 where it gave us that not a number error, that'll work different in processing because you can't actually do those things. You have to stick with the right variable type. So this is pretty simple for JavaScript. The only thing I also want to let you know is there's another way you can indicate create a new variable. It uses the word let. So I can say let grade equal, say Julianne's now graduating in grade 6. Okay. Now let and var they don't mean exactly the same thing. They have to do what's called the scope of the variable. The scope of the variable means where can you use this variable in your program. We're not going to get into that in this particular tutorial. So just bear in mind that there's a slight difference between var and let, but you could actually, if you're doing it where I'm doing it, kind of, you can almost use them a little bit interchangeably. I usually stick with VAR for the word variable. It makes more sense. Okay. Now, let's contrast this with processing. So that when you go and look at my examples, you'll be able to know what's going on. So here is the processing version. So for those of you who haven't looked at it yet, notice that the one of the big differences, instead of using the word function setup, it uses the word void setup, void draw, void mouse pressed. And again, this actually has a little bit to do with the same concept of needing a variable type. There is a type of a function called void that you have to indicate for processing. In P5.js, they don't care about these types, so they just call them the word function. Okay, that's not really important other than to see this. So here is the exact same thing. So first of all, let me pause and get my setup set up ready so I can demo better. All right, so I've added a size, a background, and the equivalent to console.log, which is just println, or I usually pronounce it print line for testing. So just to demonstrate what this looks like, I hit play. There it is over there, and if I mouse press there, you'll see down here it's printing the word testing nice and small. So I don't know if you'll be able to necessarily read these also. You can change the fonts, by the way, but I just haven't done that yet. Maybe I'll do that here right now. Okay, so I've gone under File Preferences and I'm able to change the font. You can change the font of the editor window or on the console window as well. Okay, so let's kind of recreate the same thing just so you can just see the difference. And there's not a massive thing you need to worry about other than, again, these are different variable types. And if you use my lesson plans, you'll see that we go through the variable types in a lot of detail with processing because that's required. It's required knowledge for that language. So if I want to create variables, there's sort of 5 main types of variables I use in processing. I'll show you those 5, but I'll only just example with a couple of them. So if I want to create an integer, which means a whole number, and I'm going to show you what happens if we try to do some math with that. In fact, I'm going to go grade 7. I deliberately want to put a number that's going to create a fraction if I divide by 2 or something like that. If I want to create a number with a decimal in it, we have to use a variable type that maintains decimals, and one of them is called a float. That's what I usually use with my students. Float stands for floating point number, which if you don't know math, it doesn't really mean much to you. But basically, it's a type of variable that stores the location of a decimal that can float back and forth depending on the math or not. So maybe float is a GPA. And maybe we're doing 3.5 or whatever. So there's an example of how that would work. I often use prices when I'm first introducing it, so that it makes even more sense to younger students. If you want to hold words, you need to use the word string. So string name equals Sylvia. Okay, and if you were, by the way, to try to use var name, it's just going to give you an error. It just doesn't recognize what that means. Whether you have it or something, it just gives you a full error. So that doesn't work. Actually, sorry, if I go var last name, you'll just see here that it doesn't error. Errors on var. So you have to pick the right thing. Now the other variable types we often will use is something called a char. So a char stands for character, but it's for a single letter. So maybe you wanted a letter grade, and those in processing use single quotes. So there's my letter A because I've been doing so well. And the other common variable type that I use in early going are Booleans, and we've seen that a little bit earlier, where you can save true or falses. So let's say did pass and equals true. So often I name my Boolean variables in kind of a question form, so it's easy to understand what a true or a false means. Or is passing might be a better way to write it. Okay, so there's your variable type. So let me just show you how this works. That makes it a little bit different, and I'll bring up these, the exact examples I did before to demonstrate the differences. So first of all, I'm going to do the name plus the number error. So if I wanted to go print line, and I want to print name. Sorry, just one second. Okay, so print line. Sorry, I had a little bit of a distraction there. So let's say I wanted to do name times 4, like I did in the other one, right? Which caused that NaN, not a number error. I don't know if you remember, but here it won't even let me go that far. It basically just says that you can't use the multiplication with a string and an int, which kind of makes sense. You will see, however, that it will allow me to do plus, and it will treat it the same way as I mentioned before. So down here, if I press my key, it's going to do Sylvia 4. So it will add a character on to the end of the name. And the same thing goes if I wanted to say name plus equals 4 and print line name. It will do exactly what I said before, whereas it will add 4 to the name permanently. Oops. Actually, let me do something different than 4 anyway, just so you can see what I'm getting at here. So print line 6, and there you go. You can see it saved 6. So plus equals does work with strings as well. Okay. Now, the other interesting thing, though, is what happens if I do math with integers that result in a decimal number. Let's try this. So I'm going to print grade, which is currently 7, divided by 2. So in the version with p5.js, it printed off a decimal number without any issues whatsoever. Let's see what happens here. Remember that grade is 7. So predict what it's going to do. 7 divided by 2 should, of course, be 3.5, but instead it prints only a 3. So this is interesting. What it means is that when processing and many other languages start working with an integer, a whole number, it is going to only work with it as a whole number if you only work with whole numbers. So what do I mean by that? Well, grade as a whole is an int. It's a whole number 7. 2 is a whole number 2. So it says, oh, int divided by int equals an int, and it just cuts off the decimal place. It just stops remembering the value at the decimal. So that's why I often joke around with my kids that 1 divided by 2 is 0 in programming. However, if you wanted to say, wait a minute, no, I do want to maintain this because it's just a print line. I do want to maintain this as a decimal. You can actually add a decimal number to the divide, and then it says, oh, integer divided by a float, you must want a result to be a float, and therefore it would properly do the division. Now, here's the thing, though. It will not allow you to alter that. If I said divide equals 2.0, it actually will give me an error because, again, it says, wait a minute, you can't divide an int by a float. If I do divide by 2, it will, oops, I think it might accept that in the end. Oh, not name, sorry. I meant to put number, grade. And so that works, and just to demonstrate the 2.0. Oh, it actually will allow me to type it, but I believe it will not print line. It'll only print it'll only save up to the 3, not the 3.55. Yeah, there you go. So even though it allowed you to do the divide by 2.0, it still only retains the 3. So there's the key difference. So what's the big pictures? Well, the big pictures are this. When you're working with variables, variables are essentially allocated space, oops, get that out of the way, allocated space in RAM memory to store that. In some languages, you have to indicate which variable type you're going to do so it knows how big of cupboard. Bob might end up being a very long string, so we need to allocate more space for the name than just 3 characters. Whereas other languages, the actual term is called weakly typed or strongly typed. So weakly typed means type of variable doesn't matter. We can actually do whatever you want with it. So I can even change from number to a letter, numbers to words to whatever, and it doesn't matter. And it changes the data automatically. All right, and then again, if you're working with the 2 languages, they look quite a bit different on this regard. So in p5.js, you just use the words var or let, L-E-T. In processing, you have to choose the data type. Hopefully that isn't too confusing. Again, my examples are in processing, so that's why it's important to kind of a little bit understand, even though this bootcamp is mostly in p5.js, because it's easier for you guys to learn on the online tool. All right, thanks everybody. Have a good one. Bye-bye.